So this new enhanced ACT, everyone knows that the math is super, super hard. But what is awesome is as of today, when I am recording this, the ACT has released a second practice test and the math questions on there are so much harder. So what I'm gonna go over in this video is I pulled a couple of really hard questions that was on this practice test and I will go over and explain them so that you are better prepared for your next ACT test. Hi, I'm Rebecca Beard. I own Niceville Tutoring, which we cover subjects K through 12 with an emphasis on test prep. We have over 45 teachers on staff who support students online and in person. If you're looking for some support, we have our link in the description below, and don't forget to subscribe to stay up to date with study tips and tricks. So what is the amplitude of the graph of the function f of x equals 1/2 cosine 3x plus pi shown in the standard xy coordinate plane? So most students freak out with these type of problems, but all you have to do is actually look at that front number, and then that front number is 1/2, so the answer is going to be B. So on question number 18, the sum of three positive integers is 180, and the ratio of these integers is 5, 3, and 2. What is the value of the smallest of the integers? So instead of just guessing and checking, all you have to do is add some x's to these numbers. So the way this looks is you go 5x plus 3x plus 2x, and then you set that equal to 180. And then once you add these up, that would be 10x equals 180, which would make x 18. But you're not done there because your smallest integer has a 2, so you have to go 18 times 2, which is 36. So on question number 26, an equilateral triangle, which by the way means that all the sides are equal, is inscribed in circle O as shown. What is the degree measure of the minor arc BC? So instead of panicking like most kids do, what you notice is that it's divided into threes. And then we know that a circle equals 360 degrees and BC is just 1/3. So all I do is I go 360 divided by 3. And the answer is 120, which is C. So item number or question number 32, these ones really get students stressed out. And all you have to do is you pretty much have to make sure that you're simplifying this. So let's go ahead and simplify this on the top and the bottom. So the top one, you have negative 3x to the power of 3 plus 12x. So you have to think of what term you can factor out of both of those. So on this one, you can easily factor out a negative 3 and an x, which in the parentheses, that would make this x squared, and then your other term would be negative 4. And now let's look at the denominator. So what you can easily factor out is an x. So I make this x squared minus x, and then minus 6. But at that point, you are still not done. So you need to go through one more simplifying process. So what I would do is I would factor out both of these. So you go negative 3x, x minus 2, and then x plus 2, and then x. And then this one right here, you would use your FOIL tactics and then put the x's in the front. Negative 3 and plus 2, and then you would start eliminating what is the same on the top and the bottom from there. So what I'm doing is I'm just kind of looking through. Other stuff I can eliminate is that x right there, and then so that would be negative 3 x minus 2 over x minus 3, and then what that matches right here is going to be D. On question number 40, the product of two complex numbers, x and y, is a real number that is irrational. Which of the following statements cannot be true? So irrational numbers, just a little bit of a recap. I joke that they're numbers with problems, but your best example is pi, which as you know, just goes on forever and ever. So which of the statements cannot be true if x times y is irrational? So if you think about it this way, is what can not be true? And it's actually just A, and I'm going to go over Y. It says both X and Y are rational. And the reason that it's A for cannot be true is you can never multiply two irrational numbers and make a rational number. If you think about just multiplying pi twice or pi squared, it's always going to make a crazy number. So answer on this one is A. Don't overthink these problems. Okay, so number 44 is going to be the last one we're going to cover on this video, but this one's a little bit of a beast. So you have two different hyperbolas, which most people don't remember how to graph, and then you need to make an ellipse, which, by the way, an ellipse is like an oval. It goes that way or it goes that way. So first, what you need to do is you need to get a better viewpoint on your calculator, because this is just not super helpful. So if you look at this equation here and you go into your TI 84 Plus, there is pre-coded programs on there, and it's apps, number 4 for conics. And then I am going to go to hyperbola, so I'm going to hit 3. And then what I'm going to do is I'm going to try to match this one and just get some points based on that. So we're looking for 1x squared minus y squared, so I'm going to hit enter here. And then I am going to give it the points, which I have 9 and 4, and then sometimes you have to put ones instead of zeros, so sometimes just do that instead, but we'll adjust as needed. So what we are looking for here is, let's go ahead and click trace. And like I said, I had to put a 1 there, so it's going to shift it by 1, but I am looking for the intersections on this x-axis. So right now, since that's shifted by 1, that's going to, right now it says 10, but it's going to be a 9, so I'm going to put a 9 here, and then that's a -9, and we're going to need that later. So then what I'm going to do, I'm going to second quit and clear this out, is I am going to graph the other hyperbola. So I'm going to hit enter. I'm going to go to the second one where it starts with the y squared. And then I've got 36, 25, and then we're going to put our ones there because that seems to make it happier. Okay, and then I'm going to click trace. And then that is saying 36 for this one up here. So we need to think about it this way. So we got to subtract 1. So we're going to just put 36, 36. And then now we have to find an oval that meets all of these needs. So let's go ahead and go second quit. And then let's look at the ellipse options. So first and foremost, what I would remove right away is D. That is a circle, not an ellipse. So that's pretty straightforward there. And then what you have to look at is it's going to be hard to see on camera, but on your calculator, you have little tiny pictures. And what it's saying is that this one right here is going to make that longer oval that you need. So this is what I would look through. One is that we need to be hitting our 36s. So regardless, there needs to be a 36 somewhere, and then we also need to be hitting our 9s. So you can test it and graph it out in here, but I just use these as a reference. I find those numbers right here, and then so the answer is going to be A. If you are looking to work through this full length test, I'm going to drop that below with also some resources and ways to work with us if you need to better improve your ACT score. See you then.